Okay, good morning everyone. I guess this is my second take on this because the first time I recorded it, I did not record with the correct microphone and the sound was all garbled. So this is the second go around. I've just wasted 20 minutes or 25 minutes, but maybe not. Maybe this will go a little quicker. Okay, so here today we're going to dive deep into classes, well, somewhat deep, classes in object-oriented programming. Now, before we get there, here let's define what a class is, and this is something I have always presented to my AP Computer Science principal students or AP Computer Science application students as well. So a class is a blueprint for creating other objects for children, and one way you can look at a class is like mother. We can consider mother a class. Now, classes generally have properties and methods. Properties are eye color, hair color, and complexion, for example, and the methods are things that mother can do: eat, sleep, and work. Now, you were delivered from mother. Mother has children. In programming, the way mother creates other children is by a process called instantiation. Okay, and so here mother creates child one, and that child is going to have a name Seth. And Seth is how we'll refer to that child. So Seth would be considered a reference variable. Then mother will have another child through the process of instantiation, and that child, child 2, will be referred to as Marissa. So we'll reference that child by using the name Marissa. But each child, Seth or Marissa, will inherit the properties of mother: eye color, hair color, and complexion, and the methods and functions: eats, sleeps, and works. Okay, so that's an overview of a class and the process called instantiation, putting objects in memory. All right, now a document I always provide students, okay, but this link no longer works, so I'm just going to go over what you would have done had that link worked and you've been able to complete this. But I've always found this to be an excellent article on classes, okay, in object-oriented programming. So what is OOP? OOP stands for object-oriented programming, but that isn't quite what it is. If I ever ask you that on a test and I say, what is OOP? Just don't tell me it's object-oriented programming. Yes, we know that. Okay, but specifically, what is it? Okay, that's my way of usually seeing if you really know what you need to know. Okay, please explain yourself. So object-oriented programming is a style of programming that focuses on using objects to design and build applications. Okay. Right. What is an object and what two things does it contain? In programming terms, an object is a self-contained component that contains properties and methods needed to make a certain type of data useful. So if I go back here, the class mother had properties and methods, okay, needed to make other children, which will also have properties and methods. For the two things an object contains, describe what each one is. An object properties is what it knows: the eye color, hair color, complexion, and then its methods are what it can do: eat, sleep, work. Okay. All right. What is a class? A class is a blueprint or template or set of instructions to build a specific object. Okay, so class mother, okay, knows how to build other children. It's a blueprint. And then what is meant by instantiation? Well, an instance is a specific object built from a specific class. It is assigned to a reference variable, Seth and Marissa in this case, that is used to access all the instance properties and methods. So if we wanted to know how to get at Seth or Marissa's eye color, we would reference Seth or Marissa. That is used to access all the instance properties and methods. When you make a new instance, the process is called instantiation. Also, instantiation can be viewed as the process of creating an object in memory. Okay, so instantiation. What is dot notation? Why is it used? Dot notation is used to indicate that a method or property belongs to or is contained within a particular class. Use the reference variable you declared, and we'll see that in a second. Use a reference variable you declared followed by a dot to access the instance properties and methods. Okay, so we're going to get practice in building a application using classes and object-oriented programming. We'll make this easy. Let's see here. I have put out here, okay, on Google. This is you guys will use this file. So you'll copy and paste. But what we're going to do, we're going to create a project called Bicycle Demo. Okay, and so I'll do that right now. I will create a class called a project, I'm sorry, new project, and it will be called, it's a Java application next, and it's going to be called Bicycle Demo. Oops, I gotta go up here. Just as we see it, capital B, all classes, projects should be capital. They're too important. Bicycle Demo. Okay, and when that project gets created, okay, so it sets up this package, and within that package we have a Java file also called bicycle demo.java. If we were to run this program at the command prompt, we would have to reference it by bicycle demo.java. All right, but here's an important thing. That file name bicycle demo.java must match the class name. Okay, has to. So class bicycle demo. See, if that project were to be run from the command prompt, okay, you would say bicycle demo.java. Okay, and then it would know to look for the class bicycle demo and its main method to get things going. Okay, so what we're going to do, that was already done for us, public class bicycle demo. Okay, here's my package name. What we're going to do, so we're going to copy all of this here. Okay, we're going to copy all of that there all the way to the end of the curly bracket. So copy. We're going to copy it into here. We're just going to replace this where it says public class. We'll just paste over everything. But then I'm going to change this to public class. Not that we have to, but we will. Okay, interesting. Why am I not getting some errors here? I should get errors here. I'm going to try something. I'm going to run because I should get errors. There should be an error listed here. And I think I know why, because I've already done this before. Okay, I think. And I think that class bicycle is still out there. Because when you go to do it, you'll get some red marks over here. But that's because the class bicycle doesn't exist. Basically, what we're going to do, we're going to look at the class bicycle, and we're going to create two children called bike 1 and bike 2, and that's how we do that with that new keyword. All right, but apparently it's not. I don't get that error message because it's probably already there. But what I need to do, so what you'll need to do, so I'll click on the bicycle demo, and then I'll go File, New File, and it will be a Java class. Okay, it's within the bicycle demo project, which is where we want it, and then this has to be called bicycle. Finish. I wonder if I'll get an error. Okay, it's just weird. Okay, that I did. Okay, now if I go back here, okay, now I'm getting some errors finally, or whatever. Anyway, because I don't have properties and methods of set up for that. All right, so that makes sense. All right, so here I have, so this is my class I'll be using to instantiate from public class bicycle. So I'm going to go back out here, and then I'll do the same thing, class bicycle, and I need to go all the way to the end of that curly bracket. I'll copy there. I'll go back here, and I'll just paste over all of that. Paste, and again I'll change that to public. All right, so here's our mother class bicycle, and this class here, it has properties, cadence, speed, gear, and then it has methods, change cadence, change gear, speed up, apply brakes. I'm not going to worry so much about parameters and things like that. We'll get into that. but these are its methods. Okay, so here's my class and properties and then methods. And if I go back to bicycle demo now, so what I can do, so here it's going to create bike 1 and bike 2. These are child objects or reference variables, and then we'll refer to these children as bike 1 and bike 2, and then we'll use dot notation to like change the properties of those. We're going to call this method change cadence, and basically that's going to change the cadence of that bicycle. Speed it up, change the speed of that bicycle. Change gear, change. If I go back, interesting. So they should have made these here private. Let me do this here so private. Let me just see something here. Private integer. See, if I make it private, the only way we'll have access to those properties is through methods. Okay. Things will still work, but the only way we get access to those properties is through methods, because it's private. If I had not made it private, I could have actually, I'll show you maybe. So I could have gone bike. See, here, maybe if I do this, and maybe I'm spending way too much time on this here. If I go back to bicycle, let's say here, cadence isn't private, and maybe I'm really going to. So I could go bike 1 cadence, it should come up, equals 100. Okay, because it's not made private, but now if I change it to private, and I know I'm sorry, I'm usually trying to be so thorough with this here. So, because I know where we're going. So now I get an error message because it's private and you can't access private properties of a class. Okay, the only way you can access them is through methods. Anyway, so. Alright, so here then I change the properties by calling them methods and then print states and so on and so forth. So if I go back here, it's going to print the state speed. So if I now go to run this here, if I go to run this, it runs. Cadence 50, speed 10, it prints it out. Alright, so that's an overview of OOP, Object-Oriented Programming. What you guys will be doing as we move along. After you get that programming down, that coding down, you'll be creating classes, components, and things like that. And maybe you'll have like 4 different files, 5 different files, and that will all roll up into one big project there. All right, so there. All right, so that's an overview. Now the next thing I wanted to do, you have I didn't want to go over one of the examples in the textbook, Hello Graphics. What I have done, and you may want to too, particularly when I'm accessing files. Okay, I just set up a shortcut to student files. So at any time I can click on that and go right to student files there. So I'll show you what I mean. All right, so rather than having to search for them all the time. So there's student files, chapter 2, and then Hello GUI. And then what I do is I'll click on that. Click on edit, and then I'll copy all of that there. Okay, I'll copy all of that. Okay, but what you want to do, you want to create a new project called Hello Graphics. Has to be called that exactly, Hello Graphics. Hello Graphics, because that's the class name. Hello Graphics. It has to be called that. And then what you'll do is you'll copy and paste that into Hello Graphics. Remember to keep the package name. So you'll copy and paste all of that. Import Java all the way down to the last curly bracket. Alright, and again, this demonstrates object-oriented programming, so I'm going to go over some of this. Okay, these import commands, they give us access to the libraries, or to the classes, if you will, for graphics, color, container, JFrame, and JPanel. Okay, these are all separate classes, and they have properties and methods. But we need access to those. We need access. We're going to create children from those classes, and then we'll work with its properties and methods. So that's what the import statement does. So let me run this here, and here, notice here, it creates a window, okay, and it has some things on it. So let's just go through this kind of. All right, so if I go down here to main, and I'll bring this up, okay, so when this is called, it's going to call the JFrame class is going to create a window. Window equals new JFrame, and it's going to attach a description to that window. See right there, graphics demo. So basically, it's setting up our window. It's going to set the size of that window initially, and then it sets the default. So if I click on that, it sets the default behavior to close that window. Now that's just a window, okay, but I need a drawing surface, okay, and that drawing surface will be a panel, okay. Interestingly enough, this class is called Hello Graphics, and it extends JPanel. And basically, like, what it's doing is it's inheriting the methods, the properties and methods of JPanel. When we extend it, it is in a sense like instantiating, sort of, okay, but it's inheriting the properties and methods of JPanel, this class. But anyway, here, so we're going to create a new instance of Hello's graphics, and we're going to call it panel. You see, because we could have multiple panels on a window, okay. Just because it extends JPanel, that doesn't do much for us, okay. All that does is it says, okay, you'll have access to the properties and methods of JPanel, but I'm not going to create a panel for you. You better do that on your own, because I mean, we could have multiple panels. So anyway, it's going to create a new panel for us, okay. And then it's going to set the background color of that panel to white, as you see it there. See this white panel? Well, you probably don't know. Basically, to you, it looks like a window, but there's a panel on that. But here's the deal. Okay, so because I created this window, it's a separate object, and I create a panel, it's a separate object. I need some way now to be able to attach that panel to the window. Okay, so what I'm going to do is I'll use a container class C. All right. And that will allow me to get the content pane of that window, okay, to get access to the content pane. And on that content pane, or that object C, I'll add the panel. So now I'll associate the panel with the window, and we do that by way of the container object here, right? And then I set the window visible to true. Now this JPanel, it has a method. It has a method called paint component. And basically, this paint component method is always called when I resize the window. Notice there, okay? It has to redraw the window. If I move it around, it has to redraw the panel. When I move the window around, it has to draw what's in that window. Okay, so the panel, it needs to redraw itself. All right. Now I want you guys. So imagine you're an artist and you're painting with a different color paint. So you pick up the red paintbrush initially. You pick, so G set color red, and G allows us to get at the graphic surface of that panel. And again, I know this is kind of like deep, but here I'm picking up the paintbrush color red, and I'm going to draw a rectangle. It's red. You see it. So now I put that paintbrush down, and I pick up another paintbrush, and this is going to be blue, and then I'll draw a string on it. Hello Graphics. All right. And again, this paint component method, it's a method of JPanel. It's a method of JPanel, and that gets called every time the window has to redraw itself. Now, what's this super keyword? Okay, you know, as you're working with this stuff, and if you ever have any questions, I would just Google it. You know, if you're working on your own super keyword, and here we go. The super keyword refers to superclass parent objects. It is used to call superclass methods and to access the superclass constructor. The most common use of the super keyword is to eliminate the confusion between superclasses and subclasses that have methods with the same name. No? Okay, and so why do we call the super keyword? Well, why do we use the super keyword? Well, when every time the window changes, okay, we have to do something to the panel. And here, so super paint component G. So basically, it's gonna repaint itself. Call J panel's paint component method to paint the background. Okay, so why can't the child paint the background? Basically, we're asking the parent to paint the background for the child by using the super keyword. Well, think of it this way. I mean, here's a good analogy. Mother has children, and when those children are babies, they poop and pee, but they certainly can't clean themselves. Okay, mom and dad has to change the diaper. Okay, and so when we instantiate or recreate this child object piano, okay, it's a child, but it really can't quite clean itself, or it can't paint itself. It can't paint the background. So we call the parent to do that. Super paint component G. All right, we call the parent to do that, and then now we can change the color and so on and so forth. Right. So I hope some of this makes sense, but I hope you see where we're going with this. So anyway, that's an overview of today's lesson. So carry on.